Hi, welcome to this lesson on analytical geometry, tangents to circles, part 1. Let's have a look at question 3. We're given a circle with the central coordinates c being -9, 6, and we want to determine the equation of the tangent to the circle at the points r is equal to -2 and 5. Okay, so we know that the center c is over here, -9, 6, and then we've also got another point on the circle which is r, and that is -2, 5. Notice we weren't given the radius or the equation of the circle, but this would look like it would be enough information to go ahead and answer the question, because all we are interested in is finding the equation of the tangent line, which is something like this. Okay, so it looks like it's going to have a positive gradient, and the y value, the intercept of the y value, is going to be positive number. Okay, and we expect the number to be bigger than 5 and 6 because you can see where it's positioned relative to those other points here. Okay, so first of all, let's consider the gradient of the radius line. So again, here we have the gradient of the radius line CR. That's going to be, so you can see that it's decreasing from left to right, so it's going to have a negative gradient. And from -9 to -2 is 7 units across, and from 6 to 5 is 1 unit down. So it's -1/7. That's the gradient of the radius line CR. So now we know that the gradient of the radius times the gradient of the tangent must be -1, and that again is because the radius is perpendicular to the tangent. So I have -1/7 times the gradient of the tangent equals -1. Okay, so how do I get rid of that -1/7? I times by -7 on both sides. So the gradient of the tangent is going to be +7. Okay, so that makes sense again because the gradient was going to be a positive number here. So far I've got y equals 7x plus c. Now I substitute the point of contact, which is r, -2, 5. So I get 5 equals 7 times -2 plus c, which implies that 5 is equal to -14 plus c, and if I add 14 to both sides, I get c equals 19. So, therefore, the final equation is given by y equals 7x plus 19. That is the equation of the tangent line here, and again, that makes sense. The gradient is a positive, it's quite steep, it's 7, and the y intercept did make sense to be 19 up there, it's quite high up there. Okay, so again, based off the geometrical interpretation of the question and the algebraic representation of the question, both sides match up and they agree with each other. Right, I'll see you in the next one.